Hey, welcome back to this market segmentation problem. We were just investigating an elbow. There isn't a clear tip of the elbow. I can see 3 or 4 tips which are worth trying at 2, 3, 4, and 5 clusters. Here's the limitation of the elbow method. We can see the change in WCSS with the increase in the number of clusters, but we don't really know which solution is the best one. All right, let's try 2 clusters. We already discussed qualitatively that this is probably a suboptimal solution, but it is worth inspecting the difference with standardized variables. We'll declare a variable called k-means underscore new equal to k-means of 2. Next, we will fit the x-scale data. Finally, we will create a new data frame called clusters underscore new containing the values from x. Then the column cluster pred will contain the predicted clusters from this new clustering solution with the scaled x. Here is a crucial moment. The data frame contains the original values, but the predicted clusters are based on the solution using the standardized data. This is very important. We will plot the data without standardizing it, but the solution itself is the standardized one. Let me show you by plotting the data. By keeping the original x-axis, we get the intuition. How satisfied were the customers? If we plot the standardized values, we would be deceived. The middle parts of the 2 graphs are different. This one is 5.5, and on the standardized graph, the midpoint 0 actually corresponds to the mean of the variable, or 6.4. Let that sink in for a second. If you wish, you can rewind to be sure you got that right. We will now continue with the solution. We can see 2 clusters as we specified the number to be 2. No surprise here. What's different, though, is the clusters themselves. Comparing this result with the previous one, we can clearly see that both dimensions were taken into account. Moreover, these 2 clusters coincide with our initial speculations, that those 2 would be the result of k equals 2. Okay, great! We are now much more confident that standardization is generally a good thing. However, the problem is not solved yet. This 2-cluster solution does not make a whole lot of sense, as we discussed before, but it's a good start. Let's name the 2 clusters. One contains people with low loyalty and low satisfaction, so we can call these people alienated. By the way, naming your clusters is very important. In unsupervised machine learning, clustering included, the algorithm will do the magic, but then we step in to interpret the result. My feeling here is to call them the alienated cluster, as they are dissatisfied and not loyal. No wonder. It's unlikely they'll be back to our shop. As for the other cluster, it is so heterogeneous that I'd call it the everything else cluster. All right, let's get back to the elbow. Noteworthy tips of the elbow are also 3, 4, and 5. I'll try them one after the other. With our well-parameterized code, we can just change the number of clusters in the first line, and rerunning the code would do the trick. Let's try with 3 clusters. That's the result. We have the alienated cluster once more. That's a good sign. It shows us that we were right in concluding that it is a cluster of its own, while the everything else cluster is now split into 2. I'd call this group the supporters. They are not particularly happy with the shopping experience, but they like the brand and want to keep coming back. Note that there are not that many of them. It is a small cluster. Finally, the 3rd cluster is called, well, the all that's left cluster, I guess. We can't really name it as it is still very much mixed. What happens next? Let's check out a 4-cluster solution. We have the alienated and the supporters clusters, and now these 2 new ones can also be named. Finally! The upper right one consists of clients that are satisfied and loyal. These are our fans, the core customers. Eventually, we hope that all the points on this graph turn into fans, but we will elaborate on this later. Let's name the last cluster. We have people who are predominantly satisfied but not loyal, and some of them are actually disloyal. A term I've seen somewhere to describe such customers is roamers. They like your brand, but they are not very loyal to it. We have all been there for some brand. Okay, this solution is definitely the best one we've seen so far. Here's where it stood on the elbow graph. But how about we try with 5 clusters? The alienated, the supporters, and the fans remain unchanged. These people here look like the roamers from before. Finally, these clients are almost in the middle of our standardized graph. They are almost neutral on the loyalty feature, but are generally satisfied. They are also roamers. This solution actually split the roamers into 2 subclusters, those that are extremely satisfied and those that are just satisfied. So there isn't much value added to our segmentation. We can carry on with as many clusters as we want, but from now on, we would just further segment the 4 core clusters. Let's finish off with 9 clusters. Similar to what we had a second ago, many of the clusters were further segmented. It is extremely hard to name all of them, and even if we do, we will probably need to use a lot of adjectives. For instance, the alienated cluster is split into 2, the very alienated cluster and the moderately alienated cluster. As you can imagine, there is not much to gain by using such a fragmented. In my mind, the 4 and 5 cluster solutions were the best ones. Which one you want to use depends on the problem at hand. Okay, in the next lesson, we will see what we can do with this new information. Thanks for watching.